Welcome back to Low Level Programming Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive into today's topic, I want to remind our listeners that if you're enjoying our podcast, please rate us on your favorite podcast platform. Your support means the world to us.
Absolutely, Sheila. Your ratings help us reach more aspiring low-level programmers. Now let's get into today's exciting topic. We're continuing our journey through the Introduction to Assembly Language chapter, and today we'll be discussing the role of assemblers, linkers, and loaders.
That's right, Victor. And to kick things off, I have a quiz question for our listeners. Are you ready?
I'm always ready for a good quiz, Sheila. Let's hear it.
All right, here goes. In what order do assemblers, linkers, and loaders typically operate when creating an executable program from assembly code? Think carefully about this one, listeners.
Ooh, that's a great question, Sheila. It really gets to the heart of how these components work together. I like how it makes you think about the entire process of turning assembly code into something a computer can actually run. Without giving away the answer, I think our listeners will find it interesting to consider what needs to happen at each stage of the process.
Exactly, Victor. Now, before we dive deeper, let's quickly define these terms for our listeners. Victor, could you give us a brief explanation of what assemblers, linkers, and loaders are?
Certainly, Sheila. An assembler is a program that translates assembly language into machine code. A linker combines multiple object files into a single executable file. And a loader is responsible for loading the executable into memory so it can be run by the computer. These three components work together to turn our assembly code into a running program.
That's a great overview, Victor. Now, let's start with assemblers. Can you explain in more detail what an assembler does and why it's important?
Of course, an assembler is like a translator for your computer. It takes the assembly language code that humans can read and write and converts it into machine code that the computer can understand and execute. This is crucial because while we can write and understand assembly language, the computer itself only understands binary machine code.
I see. So if I understand correctly, the assembler is the first step in turning our assembly code into something the computer can run. But what exactly does the output of an assembler look like?
Great question, Sheila. The output of an assembler is typically an object file. This file contains the machine code translation of your assembly code, along with other information like symbols and relocation data. However, this object file isn't yet a complete runnable program. That's where the linker comes in.
I think I'm starting to see how these pieces fit together. So, Victor, what exactly does a linker do with these object files?
The linker, as its name suggests, links multiple object files together. It's like a master builder combining different parts of a house. If your program is split across multiple assembly files, or if it uses external libraries, the linker brings all these pieces together into a single executable file. It also resolves symbols, which are essentially placeholders for memory addresses, ensuring that function calls and variable references point to the correct locations in memory.
That makes sense. So once the linker has done its job, do we have a program that's ready to run?
Almost, but not quite. This is where the loader comes into play. The loader takes the executable file created by the linker and loads it into the computer's memory. It sets up the memory space for the program, including areas for code, data, and the stack. It also performs any final address adjustments needed to run the program in its assigned memory location.
Wow, there's quite a bit involved in getting from assembly code to a running program. I can see why these components are so important. Are there any common misunderstandings or pitfalls that programmers should be aware of when working with assemblers, linkers, and loaders?
Absolutely, Sheila. One common misunderstanding is thinking that the assembler produces a ready-to-run program. In reality, as we've discussed, it's just the first step. Another pitfall is not understanding the importance of proper linking, especially when working with multiple files or libraries. This can lead to errors like unresolved symbols or duplicate definitions. It's also crucial to understand your target platform, as assemblers, linkers, and loaders can behave differently across different operating systems and architectures.
Those are great points, Victor. Now, I'm curious about real-world implementations. Are there different types of assemblers, linkers, and loaders that programmers might encounter?
Indeed there are, Sheila. For assemblers, some popular ones include NASM, Net-Wide Assembler, MASM, Microsoft Macro Assembler, and GAS, GNU Assembler. Each has its own syntax and features. As for linkers, we have tools like LD, the GNU linker, and link.exe, Microsoft's linker. Loaders are typically part of the operating system, like the program loader in Windows, or the exec family of functions in Unix-like systems.
Fascinating. It seems like there's a lot of depth to this topic. Before we wrap up, Victor, do you have any tips or best practices for our listeners when working with these tools?
Certainly. First, always make sure you're using the right assembler for your target platform. Second, understand your linker's options. They can greatly affect the final executable. Third, when debugging, remember that issues could arise at any stage: assembly, linking, or loading. Finally, don't be afraid to dive into the documentation for these tools. They often have powerful features that can make your life easier.
Those are excellent tips, Victor. Now, I think it's time to reveal the answer to our quiz question. The typical order of operations when creating an executable program from assembly code is first the assembler, then the linker, and finally the loader. The assembler translates the code, the linker combines object files, and the loader puts the program in memory to run.
Great explanation, Sheila. To summarize today's episode, we've learned about the crucial roles of assemblers, linkers, and loaders in the process of turning assembly code into a running program. We've seen how these components work together, each performing a specific and necessary function in the journey from human-readable code to executable program.
Thank you, Victor, for all these insights. And thank you, listeners, for joining us on this deep dive into the world of low-level programming. If you enjoyed today's episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create more content like this. Until next time, happy coding.